Let us start frequency response analysis of Nicholas chart. Myself Varun Ranjan Naik, HOD Electrical, Nilachal Polytechnic. Now I am going to explain regarding frequency response analysis having article Nicholas chart. When k is equal to 1, the magnitude of G omega is plus 23 decibel corresponding to phase of minus 170 degree. But for a phase margin of 10 degree, this gain should be made 0. Hence, if we add minus 23 decibel to every point of G omega locus, then the plot shift downwards and it will cross minus 170 degree axis at magnitude of 0 decibel. The magnitude correction is independent of frequency, and so this gain can be contributed by the term k. Let this value of k be k2. The values of k2 is calculated by equating 20 log k2 to minus 23 decibel. 20 log k2 is equal to minus 23. Log k2 is equal to 23 by 20 minus, and k2 is equal to 10 to the power minus 23 by 20, that is equal to 0.07. Result: when k is equal to 1, the gain margin is equal to minus 19.5 decibel. Phase margin is equal to minus 45 degree. Second, for a gain margin of 10 decibel, k is equal to k1 is equal to 0.0335. For a phase margin of 10 degree, k is equal to k2 is equal to 0.07. Closed loop response from open loop response. The closed loop transfer function of a system is given by Cs by Rs is equal to Gs by 1 plus Gs into Hs is equal to Ms. The sinusoidal transfer function is obtained by replacing S by J omega. So M J omega is equal to G J omega divided by 1 plus G J omega H J omega. Let M J omega is equal to M angle alpha, where M is equal to magnitude of closed loop transfer function and alpha is equal to phase of closed loop transfer functions. The magnitude and phase of closed loop systems are functions of frequency omega. The sketch of magnitude and phase of closed loop system with respect to omega is closed loop frequency response plot. The magnitude and phase of closed loop system for various values of frequency can be evaluated analytically or graphically. The analytical method of determining the frequency response involves the tedious calculations. Two graphical methods are available to determine the closed loop frequency response from open loop frequency response. They are AM on N circle, second one Nicholas chart. AM on N circles. The magnitude of closed loop transfer function with unity feedback can be shown to be in the form of circle for every value of M. These circles are called M circles. If the phase of closed loop transfer function with unit feedback is alpha, then it can be shown that tan alpha will be in the form of circle for every value of alpha. These circles are called N circles. The M on N circles are close to find the closed loop frequency response graphically from the open loop frequency response Gj omega without calculating the magnitude and phase of closed loop transfer function at each frequency. The M on N circles are available as standard chart. The chart consists of M on N circles superimposed on ordinary graph sheet. Using ordinary graph, the loss of Gj omega, locus of Gj omega polar plot is cast. The locus of Gj omega will cut the M circle and N circle at various points. The intersection of Gj omega locus with M and N circle gives the magnitude and phase of closed loop system at frequency corresponding to the cutting point of Gj omega. The M and alpha for various values of omega are tabulated. The magnitude and phase response of closed loop systems are sketched on semi-log graph sheet by taking omega on the logarithmic scale on x-axis. The closed loop frequency response has two plots. They are m versus omega and alpha versus omega. M circle. Consider the closed loop transfer function of a unity feedback system. M of S is equal to Gs by 1 plus Gs. Put S is equal to j omega. M j omega is equal to G j omega by 1 plus j omega. Let G j omega is equal to x plus jy, where x is equal to the real part of G j omega. Y is equal to imaginary part of G j omega. M j omega is equal to x plus jy by 1 plus x plus jy, that is equal to x square plus y square square root angle tan inverse of y by x whole divided by square root of 1 plus x whole square plus y square angle tan inverse of y by 1 plus x, that is equal to square root of x square plus y square whole divided by square root of 1 plus x square plus y square angle tan inverse of y by x minus tan inverse of y by 1 plus x. Let m is equal to magnitude of m j omega. M is equal to x square plus y square square root divided by square root of 1 plus x whole square plus y square. On squaring the above equation, we get m square is equal to x square plus y square whole divided by 1 plus x square plus y square. Cross multiplication, m square whole into 1 plus x whole square plus y square is equal to x square plus y square. That implies m square whole into 1 plus x square plus 2x plus y square is equal to x square plus y square. That implies m square plus m square x square plus m square 2x plus m square y square minus x square minus y square is equal to 0. Take common x square whole into m square minus 1 plus m square 2x plus m square plus y square whole into m square minus 1 is equal to 0. When m is equal to 1, the equation represents a straight line. When m is equal to 1, the equation is x square whole into 1 minus 1 plus 2x plus 1 plus y square 1 minus 1 is equal to 0. So that implies this factor becomes 0 and this factor becomes 0. So 2x plus 1 is equal to 0. That implies x is equal to minus half. X square whole into 1 minus 1 plus 2x plus 1 plus y square whole into 1 minus 1 is equal to 0. 2x plus 1 is equal to 0. That implies x is equal to minus half. When m is equal to 1, the equation represents straight line passing through x is equal to minus half and y is equal to 0. When m not equal to 1, the equation represents a family of circles. When m is not equal to 1, the equation can be rearranged in the form of equation of a circle as shown below. X square whole into m square minus 1 plus m square 2x plus m square plus y square whole into m square minus 1 is equal to 0. Divide the above equation throughout by m square minus 1. We have when m is equal to 1, equation represents straight line. Divide the above equation by m square minus 1, then we will get a square plus m square by m square plus 1 into 2x plus m square by m square minus 1 plus y square is equal to 0. Add m square by m square minus 1 whole square on both sides of the above equation. We have a square plus m square by m square minus 1 into 2x plus m square by m square minus 1 plus m square by m square minus 1 whole square plus y square is equal to m square by m square minus 1 whole square. A square plus m square minus 1 plus 2x plus m square whole into m square minus 1 plus m square divided by m square minus 1 whole square plus y square. That is equal to m square by m square minus 1 whole square. So this is equals now a square plus m square by m square minus 1 into x plus m to the power 4 by m square minus 1 whole square plus y square is equal to m square by m square minus 1 square. That implies s plus m square minus 1 whole square plus y square is equal to m square by m square minus 1 square. The equation of circle with center at x1 y1 and radius r is given by x minus x1 whole square plus y minus y1 whole square is equal to r square. So now this has become another equation. On comparing equation 3.31 and equation 3.32, it can be concluded that the equation 3.31 represents a family circles with center at minus m square by m square minus 1 and 0. On with the radius r is equal to m by m square minus 1 for various values of m. The circle given by equation 3.31 are called m circles. When m is equal to 0, then m is equal to infinite. Center x1 y1, center x1 y1. x1 is equal to m square by m square minus 1 is equal to 0. x1 is equal to minus m square by m square minus 1 approximately equal to minus 1. y1 is equal to 0 and y1 is equal to 0. The radius r is equal to m square by m square minus 1 is equal to 0. Here the radius m by m square minus 1 approximately equal to 1 by infinite is equal to 0. Hence, when m is equal to 0, the magnitude of circle becomes a point at 0, 0. Here, when m is equal to infinite, the magnitude of circle becomes at a point minus 1, 0. From the above analysis, it is clear that the magnitude of closed loop transfer function will be in the form of circle when m not equal to 1 and when m is equal to 1. The magnitude is a straight line passing through minus, half and 0.